This is Ishwara Goyal.
And I'm Nilesh Agarwal.
From Towards Scaling Inference. Towards Scaling Inference is a place where you can learn about ML deployments from zero to scale. We are very excited to have Denys, machine learning lead from Voiceflow today. Voiceflow aims to make creating voice apps easy, intuitive, and collaborative. At Voiceflow, he leads a team that focuses on NLU, generative NLP, MLOps, and conversational data discovery and augmentation. He's also a learning instructor at LinkedIn, teaching courses on GPT-4 and large language models. Thank you, Denys, for joining us today.
Yeah, thanks for having me.
Awesome. So we would like to start the interview first by understanding that, could you maybe help us share a couple of use cases of how Voiceflow AI technology has helped your customers?
For sure. I think what's interesting with Voiceflow is that we have over 100,000 different customers, ranging from hobbyists, students, to some of the biggest companies in the world. Right now, we have over 60 enterprises using our technology, ranging from retail to banking, automotive, utilities, government, quite a few different sectors. So I think on our website, we have a couple of interesting use cases. The one I wanted to highlight was BMW. They use Voiceflow for prototyping their in-car assistants. And when I was first learning about the company, I joined Voiceflow around 2 years ago. I thought that was a super interesting use case. One of the largest automotive companies in the world using Voiceflow to prototype their in-car experience.
Got it. Very interesting. And is Voiceflow's AI-powered software is built on top of like third-party APIs, or is it more of like a custom solution developed in-house?
Yeah, it's a great question. So when we started, most of the functionality was third-party that we used. But more recently, we've been bringing more and more in-house. Right now, we have more than 4 production models, depending how you count, in production, ranging from data analysis to classification models. So we've brought more and more in-house as it started to make business value. Sometimes we actually shifted away from in-house models to third-party models, which is kind of interesting, based on a business decision. So that came when we were integrating more ChatGPT and GPT-4 features into the platform. We had a generative model that we built ourselves, but it just made more sense to have it be a third-party one based on performance, cost, multilingual functionality. So we've done both, built our own, went back on it, took a third-party one, built our own, or just built one from scratch based on a unique business case we've seen.
All right, awesome. And can you just walk us through a little bit more about the process and training your custom models? Like, what were the use cases? How did you go about like data collection to deployment of that particular model?
For sure. I think it first starts off with the business case, right? So why are we building our own models? What's the benefit? Sometimes it's if we're using a third-party model, for example, for our classification models, we're using a third-party model, but we are having some challenges with operationalizing them. So for example, because we're a platform and have 100,000 customers, a lot of third-party APIs start to suffer at that point. And based on operational requirements, based on what we knew about the space, we decided to build our own model. First as an exploratory one. So we did sort of an R&D sprint for a month. And then after that, spent time productionizing it, both for English as our main customer base and across other languages too. So that journey, I think, was pretty interesting because we started off as an exploratory project, but then we started thinking about the business case. So lower operational costs, faster training time for the model, rather than using a third party, higher accuracy. So it kind of aligned. But what was interesting is that when we were building our different models, we had different requirements for the platform, which I can talk a little bit later. So at some points, we had to readjust the platform based on the model because we needed different latency requirements. So we found the business case, validated the technology, built the proof of concept, A/B tested it, integrated into the product in a beta, and now it's in production, and we're monitoring how it does, both on technical metrics and customer feedback metrics.
Sorry, I think I was on mute. So I was saying that while training, which was the framework that you used, or did you use a base model and trained it on top of that? Like, how did you go about like training a custom model for the use case?
For sure. So some of our models are unsupervised. So we use embedding-based models for those. For our custom models, we use a lot of transformer models from Hugging Face. We standardized on PyTorch, but the way we've built our framework, our custom ML serving framework, is that you can use any framework to do that. So we built a common set of APIs. So training with PyTorch, right now it's deploying that compiled model. But if we wanted to switch over to TensorFlow or another framework, it'd be easy. It's kind of interesting at the beginning, we didn't know what limitations we'd run in with each framework. So we picked one to start, but didn't go too deep into the ecosystem because things change very quickly in the ML space.
Got it. And do you guys also like have a conversion pipeline where you run like ONNX conversion or some kind of like optimization for latency inference?
Yeah, it's a great question. So far, we experimented with it, but then decided not to do it. We did have some optimizations for some of our embeddings that we ran, but just based on either the batching that we were doing, the batch models didn't actually perform better on ONNX, didn't perform necessarily that much better on our latency models. So one of our models has a 20 millisecond latency at P99, and once we converted it to ONNX, it dropped by a couple of milliseconds, but it didn't help the end business goal, and it made maintenance a little bit more tricky. So we made the trade-off in saying network latencies are much higher than that. We don't care too much. So we have explored it, but haven't pursued it just for operational reasons.
Got it. And when you're evaluating, especially the performance of your models, like so in terms of precision, like time taken, like what are the like metrics that you use to understand like okay, this is the best model for us in terms of performance? And let's say if something is not meeting the criteria, how do you refine it?
Yeah, so we ran some base tests. I think choosing our base model was really important. So we went through the library of what Hugging Face had. We looked at models of different sizes. We settled on a model within the 100 million parameter range. There were some bigger models that in theory should perform better, but actually didn't. We're sort of investigating why that was the case, but I don't think fine-tuning that larger model, we didn't leverage some of the scaling laws that we had. So based on the data set that we had, didn't really help too much. And what we found out later on is that adding data, it improved their performance by quite a bit. So when we tripled the size of our training data set, we got significant improvement in performance. We measured that mainly on an F1 score for this classification model, just to make sure that our underrepresented classes aren't just being ignored and the majority classes are being memorized.
Got it. So you're saying that it started with a lot of experimentation and like understanding what's out there in the market, but then it was like a rapid experimentation to narrow down to like which is the correct one for you, right?
Exactly.
Got it. And in terms of especially the deployment part of the process, right? Since you said that you guys have now built your own like MLOps platform, right? So could you walk us like through a couple of challenges that came, and then how do you solve it by building your own platform and like?
For sure. So I guess when I joined, I actually did a separate talk on this. I can link it in the resources as well. But when I joined, first of all, the first thing I wanted to do was understand the business case. The second one is that I wanted to make sure that the models I was thinking of using actually worked for the cases. And then immediately after that, sort of a month after joining it, it went straight into the platform building, which seems a little bit strange, but from my previous role, I knew the pain of deploying to production. So I decided before we deploy any models, right now there isn't sort of the business pressure to do so. So I'm going to set the platform right. So started building out the platform. The main sort of philosophy of the platform is how can we let any technical user deploy the model in an easy way. So it focused on model deployments. It assumed that you did your model training or your model experimentation somewhere else. I think there are some decent workflows out there with notebooks, but the challenge is once you have a model or some Python code, how do you deploy it? So we built the framework. It's based mainly on Python, Kubernetes, and Terraform. And basically you say ML create model, you give it a name, some parameters, it creates everything for you. You then insert your code into sort of specially marked areas. And then after that, you just hit ML model deploy, and then it's all taken care of for you. So that's where we focused our time. Some of the challenges that later popped up is that sort of 6 months after building this platform, 6 to 12 months, depending how you measure it, we realized that one of the new models we wanted to build, which we didn't design the platform to serve, was going to have some challenges. So originally, our latencies for retrieval, all our models are real time, but originally the latencies were around 200 to 500 milliseconds, right? So still less than a second, still quite real time. But for this new model, we needed to make sure that everything end to end, including network time, everything else, transport layer, inference, was less than 150 at P99s, which is a very low latency for sort of standard ML. There's some crazier stuff with sort of low latency computing, but in our case, our framework did not support those P99s. We did pretty well with P50s, but P99s really got us. So we had to rebuild the transport layer for this model specifically, and that took quite a bit of time because when we were building the platform, the use case didn't match it. So pretty interesting experience there, but I think definitely a valuable one because you can't always foresee what models you're going to build at what time.
Yep, makes sense.
Got it. No, very interesting. I think, so I would also like to understand that how your customers have measured the ROI, for a product like yours.
Mm-hmm. Yeah, so because we're a platform for designing, building, and deploying conversational assistants, there's different ways to measure it. For example, one of our customers, Home Depot, another use case you can find more details on the website on, but they improved their user testing quite substantially. So they were able to user test much more quickly, and that benefited their end product, right? Because user testing, rapid iteration is so important, having a good UI UX experience. So our platform enabled them to do that more quickly. We have other use cases of faster deployments as well. So Woolworths, Australian retailer, also found significant performance gains there. And more recently, we're seeing more and more customers building generative AI assistants. So given our platform and sort of the easy integration there, we have a product called AI Playground that we recently launched. That's really allowed our enterprise customers to have a place to experiment with these generative AI models without necessarily being a developer data scientist. No need to worry about APIs or how to do fairly complex prompt chaining. It's quite simplified within the UI. So I think the product has a lot of different areas to it. I don't want to go through all of them, but I think those would be some of the highlights.
No, very interesting. And what advice do you have for organizations who are, incorporating AI into their processes, or even companies who are starting in the generative AI space, right? Like, what are some common pitfalls that they should avoid?
For sure. I think the most important one is understand your use case and your business value there. I think right now we're in a hype wave for large language models, generative AI. If you watch through some of the biggest players in the space, they love mentioning generative AI and the impact, but it's not always super straightforward what the ROI is. So really important to validate the business case, validate how important generative AI will be to your product, and validate the costs, right? So if you're going to spend millions of dollars training your own model, and is it worth it, right? Because that kind of funding isn't always available to your company, right? You might have a better shot of using third-party models or just using standard NLP models, right? They're so much faster. Specialized models still do better on most tasks. So super important to validate the business case rather than being swept up in sort of a technology wave.
Definitely. Finally, my last question, like, what are your top 3 generative AI companies, of course, apart from Voiceflow, or companies who have successfully, incorporated AI, why do you like them?
For sure. I think there's a lot of interesting work being done. I think the big tech companies have certainly sort of demonstrated their ability to deliver both as platforms and end user products. For example, the Microsoft Office Suite, the Google Office Suite. I think those are really powerful and deployed at quite a scale. I mean, Facebook's done some really interesting work on the research side with Llama and other models. So there's so much interesting research and products coming out. I think one of the most interesting things that came out recently was Mosaic's framework on training large language models, sort of in a fairly hands-off way. So I think those companies are doing very interesting work. I think from a product perspective, personally, what I found most useful is I use a lot more transcription now. So using the Whisper model to transcribe what I'm saying when I'm writing blog posts or docs. I prefer to talk through things. So I'd record what I talk through, I'd transcribe it, and then I'd copy paste and format it. So that's been my most impactful personal use case.
Got it. Got it. No, very interesting. And, all three companies are in a very different kind of stream of, work and industry. Awesome. So I think, yeah, these were our questions, Denys. Really enjoyed the conversation, and especially like understanding the transition from working with third-party APIs to, moving to more of custom model. I hope it was a great experience for you too.
Yeah, thanks for having me, and happy to share with the group.
Cool.